I am a tech lead in the Tanzu application area over at VMware, and I've been working on Cloud Foundry since about 2012, 2013, when it came over from VMware to Pivotal, and then full circle now. So it's been quite a fun experience. Today I want to talk to you folks about modernizing our VM choices and infrastructures and trying to get the size of a CF deployment down to be something reasonable. So let us explore. Now, if you don't know, these three tools collaborate together to deploy Cloud Foundry, right? BOSH deployment, Bubble, and CF deployment together make a cluster of VMs that is in fact a Cloud Foundry. And this has been the case for quite a long time. CF deployment and Bubble are maybe 5 or 6 years old at this point. BOSH deployment's a little bit newer. People used to use this micro BOSH bootstrapping technique, but now we're standardized on a very similar deployment model for BOSH as we do for Jumpbox and lots of other VMs, which is really cool. But the problem is that our VM choices are bad, right? They're old and they're inefficient. And there's two reasons you should care, and it's going to resonate with you for one or the other, right? You're either like, why is this costing so much money? Or why am I burning all this, generating all this CO2, running all these servers that I'm paying for that I'm not using effectively? So this is bad, right? I think we can all agree this is bad. If you are a new person to Cloud Foundry and you deploy one and you look at how many VMs there are and how expensive they are, you're going to be fairly shocked, right? You're going to say, whoa, that's $2,500 a month or $3,300 a month. And it deploys like a huge number of VMs there. That's the full inventory for how many VMs you get. So it's a lot of VMs and it's really expensive. So this, luckily, is a solvable problem. How we solve it is going to be extremely obvious. First, we have to look at the size of VMs that existed before. And when we analyzed what Cloud Foundry uses, we realized there's only 3 VM sizes in Cloud Foundry, right? And they're all really silly names. We got minimal, we got small, which also sounds like minimal, and then we got small high mem, which also sounds like small, but I guess it has more memory. So just right away, you can tell from the names, these are not supposed to be big VM sizes. Here were the choices that we used before this migration across the 3 infrastructures. I want to highlight, we all agree there should be a difference between minimal and small, and on AWS, there are both M4 larges. There's some huge VM in the small high mem on Azure, so this is a mess. And so there's 2 problems, right? They're like too large, probably, and they're not consistent. There's no definition that makes sense between these different infrastructures about what a small actually means. So, we came up with this proposal. Basically, let's analyze, right? Let's analyze the VM sizes that are out there. Let's standardize. Take those 3 primary, 3 to 5 VM types and really standardize them. Define what a minimal is, define what a small is. Now we got to match it to the different infrastructures. Look over the 3 supported IaaSes in CF deployment and Bubble and try to figure out what's the latest and greatest, what's the right sizing for those VMs. We'll just roll out the new sizes. Oh, surprise, there's a secret second goal for this project. We would like to reduce the cost of a Cloud Foundry so that it can migrate out of VMware into the foundation. So VMware hosts between $1 and $5 million a year of open source continuous integration infrastructure. And nobody wants that because the foundation and the open source community would like to be able to cut its own releases and do its own testing, but the cost is a little too high. So we can't migrate the infrastructure from VMware, off of VMware's books onto the foundations without decreasing the cost. Now, if we can decrease the cost, maybe we can get this infrastructure all moved over into the CFF, right? And if we can get it moved over into the CFF, then, open source community is going to be able to cut its own releases, right, and own its own infrastructure. And we see this playing out in really small areas, like in BOSH, with new Jammy pipelines and Bionic pipelines. We see it playing out in the CF deployment, new pipelines that are getting set up on that working group. So, secret second goal. Next, on to step 2. Let's standardize these. There's a lot of details about what we chose here, but you got to ask yourself some basic questions. how small is too small, right? Could I use these burstable VMs where there's not much guaranteed CPU capacity? Is that going to be acceptable? If I downsize, something bad going to happen? Like in Diego, by the way, you downsize someone's Diego cell, they just lose half of their memory capacity, right? So like the amount of memory on Diego, it turns out to be part of your interface. So it's a little scary to downsize it. You should think about those effects. This is what we came up with. So basically everything is different except one VM, and everything is cheaper. So that's great. You can see a lot of burstable sizes. If you know these infrastructures well, you'll see burstable sizes everywhere. The B series, the E series is burstable, the T series on AWS. Every one of these is burstable. And so we decided that burstable was acceptable as long as it was able to maintain a certain baseline. We can't have you burst down to like a VM that has basically no guaranteed baseline. I was really worried about Amazon. I was like, oh, they only give you like 10 or 20% CPU guaranteed baseline, right? And I was like, that's not enough. Then I read the fine print on the T3 series, unlimited burst. You can burst as much as you want all the time, all day, every day. They will charge you for it if you do too much bursting, but like, this is exciting, right? So there's a lot of analysis that went into these. The second thing you'll notice is that they are all the same, basically the same, right? We now have a definition for a small high mem. It turns out it was 2 cores and 16 gigs of RAM the whole time. No, it wasn't. We just made that up, but it's actually standardized now, right, across these different tiers. You'll notice much cheaper also. Great. Good job, everyone. This is going to be amazing. High fives all around. We'll just, roll out these new sizes, and we'll just leave that little implementation detail for the reader. And look at this great cost savings we're going to get here. Those graphs are definitely lower on the right. Now we actually have to roll this out. How do we change the VM sizes on Cloud Foundry again? There's like 4 ways you can get tricked into thinking that you're changing the VM sizes on Cloud Foundry. There's like VM sizes just all over the place, and you're like, I'm going to edit the one in CF deployment, wrong. I'm going to edit the one in BOSH deployment, wrong. There actually is a Go file inside of Bubble that we discovered is actually the one where the orange arrow is. That is how you change the deployment, the size of the VMs in Cloud Foundry. But the director and the jumpbox VMs are a little bit more obvious, like they're properly associated, right, with the BOSH deployment or with the jumpbox deployment. So once we figured out that was the right size, edited it, had to make a variety of PRs and released a new version of Bubble, right? And a new version of BOSH deployment and jumpbox deployment. This took about 9 PRs across like 6 repos, because like there were actually a lot of changes. There were a lot of submodules. I don't like submodules, but we had to update them. It wasn't great, but we rolled this thing out successfully, and there were absolutely no problems. There actually was a problem. Matthew's like, hey, wait a minute. We're seeing a lot of failures that we weren't seeing earlier. How much testing did you do? And at which point I explained to him, we were always going to test it after we released it by gathering a lot of data about how it fails, right? Because these are flaky scenarios, and it's hard to predict exactly how frequently we're going to get flakes. So we commenced rapid analysis, right? Trying lots of permutations of how you run cats, lots of permutations of different VM sizes, right? Different infrastructures and so on, measuring whether they're green or red. Matthew and I went back and forth, Matthew Coker a lot. He was really helpful. And we figured out basically how to get this consistent by tweaking the cats, by tweaking the VM sizes just slightly. And some more emergency PRs later, we were able to finally realize some cost savings here, and this is what it looks like. That's a big number up there, and that becomes a smaller number there. And if you look at these different colors, these are Google colors like of different SKUs, and so like a couple of the SKUs just disappear. The N1 SKUs just disappear and are replaced by new colors that represent the E2 SKUs, which are the much cheaper SKUs. Cool. So what now? We did it. Huge success. Cost of a long-lived CF deployment has fallen. I mean, this thing costs $600 a month, and it used to cost $2,000 a month. So I would say huge success. Concourse benefits, any BOSH deployment benefits if you're using the standardized VM sizes, small, medium, large, small, high mem, minimal, medium, high mem. We only standardize like a handful of VM sizes. And if you want to take advantage of the new VMs, you can name them directly too. Like there's new sizes available. On Google, you'll get E2 standard 4, right? On AWS, you'll get M5A X large, whatever. All you have to do, of course, is upgrade Bubble and Bubble Up. Otherwise, this won't take effect. And this means that there's now enough CFF budget, right? It means that there's enough budget to run a concourse and a CFD per working group, and people can move these pipelines over. Now, it's not easy to move these pipelines over. I don't want to trivialize that, but we have the money for it now in the CFF, and the working group leads are tasked with creating concourses that all of the teams that they support and the projects they support can move their pipelines into. We don't have like enough budget to have concourse per team, but we have enough to have a concourse per working group and like a permanent CF deployment or 2 per working group. Cool. So all they had to do was bubble up again, right? All we all had to do in this room was bubble up and, and deploy, right? So everybody did that, right? The answer is no. Nobody did that, basically. This is the financial metrics I look at, and for how much N1 across the open source stuff, how many of the different Google SKUs we're consuming. The red and blue at the top are N1s, and you do see a small drop in those N1 consumption and a small increase in E2s right there. But that's not much, right? We haven't actually moved that much over. We have the power to pull this graph down pretty far, to $1,000 or $600 a day. But we have the power to pull that down pretty far if we want to. So please go back and do this. If you use VMware Toolsmiths, and this is like a semi-proprietary thing we do that then the open source community does, then you're like, whoa, that doesn't make any sense. But if you do it, good news, we were able to roll it out unilaterally without talking to you, right? Because these are pooled environments that get recycled, and they just got recycled automatically, and you can see the drop from when we rolled it out. It's also cyclical, so you can ignore the cycle, but if you look at the maximum, you can see it drop. So here's my action to you. Go bubble up your environments, and don't forget to deploy after you bubble up, at which point the new VM sizes will be in place, and then the cost of all of this will go down, and we won't be generating nearly as much carbon. So anyway, thank you for listening to my exciting financial talk here on cloud finance. This is one of my favorite topics. I'll talk cloud finance, VM sizes, hyperscalers with anybody who wants to, any day. And anybody have any questions on this since I finished a tiny bit early? Yeah, you can yell it. I can repeat it. ARM, yeah, right? I was like, we'll go into M6, right? Or whatever, grab it, MG, what's this G thing? And it's like, uh-oh, that's not an Intel processor, that's not an AMD processor, that's an ARM processor. So what does it take to get us into like those really low cost chipsets? Probably a ton of stuff, right? Like you try running containerized Intel applications on top of ARM. The reality is we are running a platform to host applications that we didn't write. So those applications usually are Intel or AMD applications. So even if you can get all of Cloud Foundry and all the stem cells to work on ARM, someone's going to want to run an Intel application, unfortunately. It's like Windows, it's like this whole extra architecture that you need to support. So it would be like an and, not a conversion, unfortunately. So you could have a pool of Diego cells that run ARM workloads. Right, we could have a pool of Diego cells that run ARM workloads. We could have build packs that support ARM workloads. Ryan's already gone. But anyway, you get the idea. So there could be ARM support in the future, but I think it's like a pretty big cross-cutting concern, and it would look like a isolation segment that only runs cells and they support ARM. Other questions? Okay, well I have good news. There's only one more talk left. I'm going to turn it over to Ram to introduce Carson. Thank you.